Hello, my name is Asante Indlela, and in today's lab, I'll be reporting on a lab that I designed on my own. So for this experiment, I chose to do an investigation of projectile motion in the X and Y directions. The model used was a basketball that I feel like stays ahead of me, and the physics principle applied to this experiment was Newton's second law, which would state that the net force acting on an object is directly proportional to the rate of change in momentum of an object. So here is a video of me throwing the basketball. And then on top of that, I wrote some glow script code, as you can see here, to make a computational model of this experiment. And when you run it, you get the path of the object, you get a graph of the Y position versus time, X position versus time. Here, the Y position graph is curved and X position is straight. And then to get data from the model, I use trackers such as here to get these graphs, which I'll elaborate on in a sec. So these are the graphs I got for that basketball I threw. Here is the X versus time, and here is the Y position versus time. These graphs are quite similar to the model. The X graph is relatively straight and Y is kind of a smooth curve, which is very similar to the model that we got in GlowScript. So what conclusions can be drawn from this? Velocity in the X direction stays relatively constant. So that implies that the net force acting in the X direction is 0. Velocity in the Y direction changes. This is because the force of gravity acts on the ball and therefore causes the velocity to change. This produces a curved motion path, such as in the experiment and the GlowScript model. In this experiment, two main assumptions were made. There was no direction in the Z direction, i.e. it didn't go towards or away from the camera. And air resistance and drag are negligible, as in air resistance and drag on the ball in any direction are so small, it would not have had any effect on the results of this experiment. Thank you for watching my video, and I hope you enjoyed.